Hello class, today we're going to go over section 6.4, examples 3 and 4, which are pretty much the exact same thing, only one is slightly longer, exact same process. Now remember, example 1, we saw an improper fraction, or a proper fraction, just regular factoring at the bottom. Example 2, we saw an improper fraction, and we used long division in order to allow us to factor the remainder, continue working. Example 3 and 4, we're going to have denominators that include repeat zeros. Again, for people that need a refresher, repeat zeros are pretty much factors that are repeated more than once. For example, here you'd have -2 twice. You could also have, odd degrees. That's fine. You could have it outside a parentheses. That means 0 is a repeat. 0, etc., etc. So here, again, let's do the normal process. Let's factor the denominator. Now, step 1, I have greatest common factor. I'm going to get rid of an x in every single term. And after I factor this trinomial, I'm going to be left with this expression, x plus 2 squared, because 2 plus 2, 2 times 2 is 4, 2 plus 2 is also 4. So when you factor this denominator, you end up with this expression, meaning that my -2 is a repeat 0. This factor is repeated twice. So when you're going to break these down, what you actually have to do is do the following. Now you're going to write your first variable. It's just going to be an x. The second one is going to be only one of these repeat zeros. Only one, first degree. Even though there are 2 here, I'm only going to put a 1 here. And for my third term, I'm actually going to write my repeat 0. Now, in order to represent this, you do have to put it like the repeat, the 2, 3s, 4s, 5s, 6s, etc., etc. Every time you have multiple repeat zeros, in order to differentiate all 3 of these fractions. So again, let's say you have x plus 3 cubed. Let's say I have this expression. The first denominator will have this, the second denominator will have this, the third denominator will have this, the fourth denominator will have this. Oh, 3, sorry. That's how you differentiate all the repeat answers. So in this case, since I have 2 repeat zeros, the first one will just be first degree, and the second one will be second degree, which is the repeat. Now, one thing to keep in mind, when you factor this expression, remember, the expression was this. Now, here's where this factorization is going to be important besides just splitting it up into different fractions. When we were working with 2 terms, let's say, for example, this exercise, when we were working with 2 terms, all we did was cross multiply in order to find my a's with the parentheses and the b's with the parentheses. We just cross multiplied. When we have 3 elements, as in this case, you can't just cross multiply because I have other terms. What you do in this case is you multiply each letter by the lowest common denominator, which is actually the factorization answer. So let's see what happens. When I multiply a by this expression and then divide it by x, you simplify. I'm left with a x plus 2. That's my first term. Now I'm going to multiply b times my lowest common denominator and divide by x plus 2. I simplify, the square goes away and this goes away. And I'm left with b x plus 2. When I multiply by c, by my lowest common denominator, and then divide by x plus 2 squared, this goes away, and you're left with plus cx. And all I did here was get rid of my denominator. Again, remember, you multiply it here and you end up with this expression. And also remember, this expression is equal to this. That's how I'm gonna get my answer. -1, -3, 8, and is equal to this expression. Now, what I'm going to do is, actually, and I forgot a square here, I apologize. When you divide the 8, I was missing my square. Now notice that the answer should look something like this. A term should be squared, a term quadratic, a term should be linear, and again, just another term at the end. But it should have something like this, multiple different degrees, so you end up with multiple different answers. So now, all I have to do is the exact same process you've always done. Distribute your parentheses, so distribute these expressions, group them as far as degrees go, build your matrix and solve. Now I'm gonna do this one. Remember, you have to expand your binomial. The expansion of that, let me just go ahead and do it. The expansion of this binomial is x squared plus 4x plus 4. When you multiply this term by itself, you end up with this. Remember, it's not just x squared plus 4. There's also a middle term there. Plus bx, again, I'm just rewriting these expressions. So all I did there was expand this binomial. Now I'm gonna go ahead and distribute. I have ax squared plus 4ax plus 4a. Here I have plus bx squared plus 2b, and here I just have plus cx. And remember, all of this is equal to the original numerator. Now let's start grouping them up. I always suggest you begin with highest degrees and then go to lowest degrees, like standard form. So here I have an x squared. Here I have another x squared. Those are my only two x squares. So that's gonna form a nice group there. Now I'm gonna look for my x values. For a x, actually, hold on, I think I did a small mistake here. Yeah, this had an x here also. I did not distribute properly. Here, I ended up with bx x plus 2. When you distribute, I have bx squared, which is here, and then 2bx. I forgot the x down here. So I fixed it. Now I have 4ax. I also have a 2bx, and I have also a cx. All my x's are together there. Even though this looks like a parentheses, that's actually a very ugly C. Now you're gonna look for the terms that do not have x's. This has an x, this has an x. 4a, that's it, I'm done. Now remember, the quadratic terms will be equal to the quadratic term here. The linear terms will be equal to the linear term here, and the constant here will be equal to the constant here. So when you build your matrix, you're gonna have 1 plus 1, or actually let's use letters here, it's easier in this case. A plus B is equal to -1. Now I have 4a plus 2b plus c is equal to -3. And here I have 4a is equal to -8. Now via substitution, you can tell that your a is -2 when you isolate the 4. So you get rid of the 4, you end up with a equals -2. Now when you plug -2 in here and isolate the b, you add +2, and -1 plus 2 is +1. Now when you substitute here, -2 times 4 is -8, and 1 times 2 is 2. You add these two, I end up with -6, and when I isolate it here, +6, 6 minus 3 is 3. So C equals 3. And there's your answer. Again, the only difference with this process and examples 1 and example 2 is that when you end up with a repeat 0, you have to differentiate it in the denominator. That's it.